The energy transition is not a concept anymore. It's a reality, happening at the edge of the grid every second. More solar, more EVs, more distributed energy, more complexity. But a cleaner grid only works if it's also a smarter grid. Today, we're showcasing how 5G is becoming the missing connectivity layer for modern power utilities, powering next-gen AMI, enabling DR visibility, improving outage response, and supporting EV-scale electrification. Utilities used to manage predictable flows, generation, transmission, distribution, customer. Now the grid is bidirectional and decentralized, solar exports, home batteries, EV charging spikes, and new loads appearing everywhere. To operate this new grid, utilities need something foundational, a dense sensory layer at the edge, meters, sensors, controllers, feeding data back and receiving commands. Utilities typically connect the field using 3 pathways. RF mesh for dense coverage, PLC over power lines, and cellular, including LTE-M, NB-IoT, and now 5G. Here's why cellular, and 5G in particular, is strategically interesting. It can connect endpoints point-to-point using existing infrastructure, reducing the need for utilities to build and maintain large private communications networks. But it's not a replace-everything story. Most utilities will land on hybrid, using 5G where it matters most. Let's showcase the real value, not theory, operations. Next-gen AMI moves from periodic reads to more event-driven intelligence, more data, more frequently, with faster response. 5G helps when you want higher throughput, lower latency, and scalable device management, especially across mixed territories and dense device environments. With rooftop solar and batteries, customers become prosumers, and power flows both ways. AMI 2.0 can monitor injection and improve net metering accuracy while helping prevent local overload and voltage issues. 5G becomes valuable when you need reliable wide coverage and low-friction connectivity for distributed endpoints. EVs are a cornerstone of electrification and also a grid challenge. AMI 2.0 supports local monitoring to coordinate charging load, reducing draw during peaks to prevent local brownouts. 5G shines when coordination needs to scale fast, lots of chargers, quick response, and edge intelligence. When outages happen, speed matters, detecting location, dispatching crews, verifying restoration. AMI enables outage automation, but the network must hold up under stress. 5G can support priority service, especially in private or sliced deployments. Utilities don't just want meter connectivity. They want a multi-service field network, AMI, distribution automation, EV infrastructure, and more. 5G can complement this as backhaul or as direct connectivity where mesh density is weak. In utilities, connectivity is operational technology, critical infrastructure. So 5G doesn't remove risk. It changes the risk model. The correct question is not, is 5G secure? It's, how do we enforce security end-to-end and define ownership between the utility, vendors, and telcos? Utilities have long suffered vendor lock-in and communications. That's why interoperability matters. Open ecosystems and standards help keep architectures flexible as technology evolves. Here's a practical deployment playbook. Step 1. Define traffic types, meter reads, power quality events, DR/EV coordination signals, firmware updates. Step 2. Map territory reality, urban density versus rural coverage. Mesh may excel in one, cellular in the other. Step 3. Choose a model public 5G. Fast rollout, broad coverage, higher dependency and subscription cost model private 5G. More control and tailored QoS. Higher design and integration effort hybrid. Often the real-world answer. Private in critical zones, public for wide area, plus what already works. Step 4. Pilot with KPIs, outage detection speed, restoration verification, EV peak reduction, data completeness, security drills. The energy transition needs more than renewables. It needs coordination, visibility, and control at grid scale. 5G isn't the smart grid, but it can be the connectivity layer that makes next-gen AMI, DER integration, EV scale electrification, and resilient operations achievable.